Lovely, thank you so much for coming back. We are maintaining the highest levels of expertise at our conference today. And with this, I'd like to introduce to you our next keynote speaker, Hana Dusíková. Now, Hana is a staff software engineer at Woven by Toyota. She is known for the compiled time regular expressions library. She also chairs SG7 study group for reflection and co-chairs the evolution working group. Wherever she goes, she represents her native Czechia. Now, fun fact about Hana is that she lives with an Italian greyhound, and as you can see, she's got a very cute roommate. And my idea now is that we show our special appreciation to Hana being here and our special appreciation to our neighbor, which is Czechia. So does anybody know the Czech word for ice cream? The pronunciation dictionary says zmrzlina. Is that anywhere near? Okay, so everyone, zmrzlina. How's that? Okay, all right. We've got another one. So back to the roots in Czech, according to an automatic translator, is zpět ke kořenům.
Zpět ke kořenům.
Okay, everyone.
Zpět ke kořenům.
And one more.
Zpět ke kořenům.
Okay, we are back to the roots with Hana Dusíková.
Hi. Okay, this is a really scary room, by the way. You should stand here. Okay. I have a talk. It's called My Favorite Data Structures, but it's kind of like not what you expect. I work for Woven, and I'm Hana, and let's start it. Recently, in my work, I'm hacking Clang compiler. I'm as part of fix things which always bothered me, and I have the opportunity to fix them now. Also, I like to learn how compiler works, and also can implement changes into language, which I propose, which makes it much easier to propose them. So, how many of you have some experience writing interpreter or compiler? Please raise your hand. Okay, it's like 1/3, maybe 1/2. Okay, so in Clang there is a thing called constant evaluator. Constant evaluator evaluates C++ for constant, obviously. It's module called expr constant. It interprets C++ as specify, and it's all in one file. Whole C++ for Constexpr is implemented in one big file, 17,000 lines of code. And my clickers, it's independent of your CPU architecture, so it works on symbolic execution, and it doesn't care about your CPU anything. And also implements the C++ abstract machine itself. Abstract machine is the important word because it's an abstract. There is no connection to real hardware or anything. So you need to forget about CPU architecture. You need to forget about values, memory, pointers. Are you ready? Yeah, okay. So, symbolic execution. Everything is a symbol. There is no such thing as byte, no such thing as address. So, what's a value? Value in Clang, because the Clang, as it models the symbolic execution, we can explain Clang and you will see how it works. So AP value is a thing which holds a value. AP, I asked Clang developer and they were not sure what it means because it's quite old. But after some digging, it's arbitrary precision value. It can be nothing. It can be integer with some value in it. It can be float of any precision of any type. Even the integer can be any, like 1,000 bits long, it doesn't care. It can be array of other values. It can be union of values. It can be structure of values. And it can be L value, reference or pointer. So array in Clang is implemented as three things: pointer to data, size, and capacity. So you have array of items, in this case 12, and you can have it initialized with some values, in this case only zeros. But it doesn't care. It can be even like mixed values, because the interpreter is a little bit wider than the language itself, but in C++ mode, it won't allow you to put there anything else than same type. Union is just, you have some code, meaningless code, and union is two things, field and value. Field is a pointer to AST, representing the field in union which is active, if it's active, and value is another AP value containing the value, in this case integer, another integer, or it can be float, or it can be object. There is no such thing as a size or object. There are no bytes, nothing. They are just values. Structure is, in this case, we have three structures, and circle is inheriting from position. Position contains two floats, and there is also color with RGB. So such structure, sorry, it stopped working. I will. So value is three things again: data pointer, and also number of bases and number of members. So in this case, we have like bases, members, 1, 3, and then we have data. In this case, are 4 values in our structured circle. 1 for base, which is structure, and first member, float radius, and color, which is another structure, and another structure. And that's how you implement structure in Clang interpreter. From structure, there is like pointer to another structure, and it's like tree. So if you have like sub object, it's just sub tree in your like main object. And so. So what is a pointer? If you are implementing your own interpreter, how do you implement a pointer? If there is no address in memory, you have value, and you need to somehow to point at it. But how? No address. You can use AST location as identifier of the object. Sorry. So, what can be pointed by pointer first? It can be nothing. It can be null, or null pointer in modern C++. It can be initialized object of type A, or it can be initialized object of type B, or it can be array of objects. And you can move in the object array of objects to not object. And you can even point past the array, or even past objects, initialized or uninitialized. Doesn't matter. So, if everything is just a symbol, how do you order? In hardware, some people think you can order pointers if you have linear memory. But if everything is a symbol, how do you order these two items in memory? A, B, or descending order? I don't know. Or what if there is C in middle? How do you sort them? There is no meaning in sorting addresses. That's why C++ doesn't allow you to sort, to compare pointers if they are not into same main object. It can be even more into dimension and some undefined value. It doesn't make any sense to sort them. So, first, I use like term main object. Main object. And for that, we need to also learn pointer provenance. So we have structure x, y, z with 3 members. As I showed you how structure looks like, we have 0th, first, and second member, because we are 0 indexing. And we have items which contains array of data and count. It's just example. So we have like 8 members and count. Is this okay with you? Like, that's how you manage things in memory. But you can do this. So you can take pointer to data 8 member, which is past the end, and pointer to count, and they will be same address or same thing. And that's wrong, because these pointers are not the same logically. Symbolically, they are totally different, unrelated. So like thinking about pointer provenance, you cannot do this like linear memory thing anymore. And you shouldn't do it at all, because in runtime, it will just lead to error if you do this. You will hurt yourself. So no, this is wrong. You need to think that array is just sub-object. So we have structure of 2 items, data and count, and array is another sub-object. And then we can also have like some upper object which contains just items, nothing else, and that's here. And now I can have pointer to the object, which can be somewhere on like stack, heap, whatever, doesn't matter. And I take pointer to it, and I have pointer to object. It's somewhere in program as an AST node, so I can just point at it. But how do I point at sub-objects? Because there is no address. There is only pointer provenance. Imagine it as a path from top to bottom, which navigates you how to find your object. So you can do pointer to first member of the main object, which is the items, and from there you can go only down. You can go always only down. So you can go to count, or you can go to data. Data is an array. From there you can get pointer to member of the array, and from there you can go to sub-object in the array. It's simple. The simple rule, you can go always down. No other direction, with one exception. For array, or arrays, you can just, this is like path plot here. You can just, yeah. Also, if you have like pointer at x, you cannot go to next pointer. You need to go from pointer on the top. So yes, you can do this. But if you have pointer at the array itself, you can just move to next object. That's only guarantee which pointer provenance gives you to go to your neighborhood. And you can do, it's happening. Okay, I think I need to use the next clicker. So yeah, then you can like nicely go to next object. Okay, so if we have model that your object is a pointer, it's some like AST thing, AST node. What's the difference between L value and R value? Is there any difference between L value and R value when you program C++? When you like code something? R value, someone said no address, but R value is always also address. Difference is R value just says, we have L value left, right, obviously, but R value just is same type of reference or pointer which just makes, this is marked as temporary. You can steal from it. It will be soon destroyed. Maybe. You are allowed to. There is no other difference than this. So we need to talk about lifetime. We have global variables in your program. They start before you go to main, and they will end after you leave the main. There are scope-based variables in your scope. They behave as LIFO, so last in, first out. So last variable is initialized is destroyed first. Temporaries are part of your expression. Every time you create some temporary, it can have address itself, or it can be in a register. And compiler knows that, and if you try to get address, it will move it to memory. Otherwise, it can be in a register if you want. But that's hardware. Sorry, we shouldn't speak about hardware here. So temporaries are just variables with different lifetime, only for expression. And then we have heap allocations. Heap allocations are like the thing you control, and they are starting exist inside of the expressions, but they actually do not end at the expression, so they are like more like this. It's a leak, let's say, but it's up to you to control it. Also, temporaries can be lifetime extended, and you can assign them that they are now scope-based or even global. This is like lifetime model in my mind, how I see it. So, identifier of object is its location. Global variables are identified by name because you have like const variable A or const variable my global game state. I don't do that. Local variables are identified by AST node and a version. I will get back to it. Allocated values are identified by unique key. Every time you allocate during constant evaluation or in symbolic execution, you will just get some unique cookie or key identifying this is your allocation. So again, what's a pointer? Let's have like, here. Structure coordinates, x, y, and we have function, setting the variable x, y, and we have pair of values, and we take pointer of it. So AP value is three things for the pointer. Var declaration, which is just pointer to the variable itself you are pointing at, and version. Every time you call a function, you increase version. So that's how symbolic execution engine knows if you have somehow pointer to some local variable from previous execution. So it will tell you error. So it can detect UB. Because Constexpr engine and abstract machine doesn't allow any UB. Everything must be detected. Not every compiler does that, but Clang is trying really well. And third thing, provenance. Provenance, yeah, we have a few versions every time I run it. And if we look into subobject.x, we need to change provenance. And here it's just path to first member inside of the object, x, or y. That's how symbolic engine sees pointers. Okay, that's pointer to local variable, but also we have allocations. In this case, it's a pointer to some allocation somewhere. It's a structure. And it's a pointer to expression, so we know where this specific allocation start to being alive, and also key, which is just number. And every time you allocate, it's just different number. And if you want to go to inside, into array, you need to use provenance again. So path 0 takes you into the first subobject of the object you allocated, the array itself. And if you want to go inside, you need to extend the path to two members, 0, 0, and so on and so on. Okay. Pointer to static variable. Static global variable. There is always only one behind its name, if it's not templated, but that's just instantiation. So it's just pointer to the AST node itself and to declaration. And inside of the AST node, Clang stores the value itself. And if you have some subobject, you can use provenance too, but not in this case. So values you create, you store somewhere. Global variables inside AST nodes. Local variables in stack data structure. Allocations are in a map. Yeah. And all these are data structures you use to model execution. And then constant evaluator just walks the AST. AST is just tree-like data structure, and it goes recursively from the top to bottom, and if there is a plus expression in expression, it looks on left and right and evaluates them and gives you a result. It's really simple. I mean, the code is complicated, but it's not that hard. And everything I show you is implemented in C++, which is sometimes confusing because to implement in C++, you are using C++, and if you want to implement new feature, let's say exceptions, the best thing to model them are exceptions in the language. It's confusing. But it helped me understand how to use C++ and how the abstract machine works. You shouldn't, like, unless you do something really low level, think about what's happening in your memory on bytes, because compiler doesn't see that. Compilers see abstract C++, and it optimizes based on that. So if you're accessing past the array, it's something which cannot happen, and it means it's UB, and it can do weird things. But compiler interpret can detect these, because it has much more information, metadata about it. So, in my mind, Constexpr interpreter is just another machine C++ is running on. Because C++ doesn't define anything like stack or memory. It just, everything is symbolic. Yeah, what's happening? So, in my mind, the standard library should be constant evaluable. Do you agree that, okay, I will ask you a question. Where would you put line, what should be Constexpr and what shouldn't? Just shout. Do you is it, sorry? I/O. I/O?
When a function reaches the outside world, reads from somewhere.
Yeah.
Then it cannot be constant.
Okay, from our audience, if your program reaches outside world, which is not known during compilation, then it should be Constexpr, which is exactly my personal model. If you cannot observe universe, and if you cannot break your repeatable build, so by design, the feature will give you always same result, then it should be Constexpr. Yeah. Good one. So, but most standard library is not. And I found it really sad. So let's do a quick test. What containers in standards are Constexpr compatible? Array. Just raise your hand. Is array Constexpr compatible? I'm getting 2/3. Yes, it is. So, Deque. Did you use Deque? Only I see 3 hands, 4, 5, a little bit more, but I cannot see in back, sorry. Deque is not Constexpr compatible. You cannot use Deque in Constexpr. Flat map, which is new data structure in 26, I think. Yeah, Andreas is nodding. Flat map, new data structure in modern C++. Is it Constexpr compatible? Raise your hand if you think so. Sorry, it's not. Flat set. Also, no. Forward list, which is one-way linked list. The simplest data structure, probably everyone learn as a first thing at computer science courses. Is it Constexpr? Only few hands. It's not. In place vector, new data structure in 26. Is it Constexpr? No. You know more details, but yeah. Yes, but with asterisk. It cannot be used for Constexpr type which are not trivially constructible. We are trying to fix that, but we don't know. We have some theory how to do it, but still we are working on that. Oh, sorry. Yeah. Hive. Hive is data structure which guarantees you pointer stability. Every time you create object there, it will never move. It's really useful for game development, networking, simulation. It's not. It's going to 26, and it's not. List. No, we didn't have forward list, so it would be weird. Map. Yeah, Exactly. Optional. Is it now it's data structure because it has begin end, so it's container. Some people disagree, but you can use it as a container for one member or 0. It is. Set. No. It makes me sad. Basic string. It's also data structure. Yes. You know C++. I have nothing to teach you. Under that map. Nope. Under that set. No. Val array. No. I care. Yeah, I care, exactly. Val array is like, you know the meme, Mom, can we have symped? No, we have symped at home. So, vector. Yes. And do you know why is this like, this table looks like this? Yeah, by the way, there is a paper from me which will fix this for all the containers with exception of Hive, because when I was doing the paper, Hive wasn't in draft yet. But I should update it probably. So, let's look on some containers in details. Just array. You create array. You create something like val array for array, and inside you construct elements. And elements, and you initialize them from the left to the right. And if you don't provide enough members, it will initialize them, but in unspecified state, but they will be initialized. If it's trivial type. If it's not trivial type, it's a little bit problematic. You can take pointer to begin, you can take pointer iterator to end, you can take iterator in middle, you can move iterators, you can go to end, fix security bug, you can change the values. Because you can write in, and if you change it, iterators are stable. And you can change also to this. Array, simple. And it's destroyed from the back to the front. Okay, vector. It's 3 items. In my mind, Andre, it's pointers, not pointer and sizes, but it's depend on implementation. But so I have pointer to data, pointer to size, and pointer to capacity. So I allocate 4 members, and I will put some values there, A, B, C, D. Okay, and if I grow, I need to allocate new storage, and I need to move out previous values. But if I do this, and my type will throw exception, suddenly my my vector is broken because part is in one storage and one in another. So I cannot do that. If I can throw exceptions, then it needs to be copied like this. And then pointers are changed because we know it's safe now, and then we can safely destroy the objects in the storage, but not from the back to front, but from the start to the end. Vector is weird in this sense. Okay, and then I can continue, and maybe I get iterators. And what will happen if I put something into vector? It's fine. But now I need to allocate, and my iterators are no longer pointing at something which is my vector. So your iterators are stable only when you're not modifying the vector size or capacity. So let's say, because in this sense, maybe I still have iterators, and maybe they still point at some like moved out value, but I don't know. So I need to destroy them, and suddenly they're gone. So, and then I move stuff there. I can also like take iterator, and I can delete item, and delete is just moving stuff to the end, like this. And then I just change size at the end. Or I can take range of iterators and delete 4 members in this case. And I will do only like this thing. And I will move the 4 spaces at the end, and then destroy them from the left to right, and then move size. That's a vector. And it's destroyed again from the left to right. And it's defined like this. So list, I can put thing at the end, at the back. I have two pointers to previous, to next node. Everyone knows list. I can take iterator, and even if I'm modifying the list, the iterator is stable. But use list only for really big items, because otherwise it's not efficient. I can also remove from the back or remove from the front. It's all one operation. I can even remove something from middle if I have iterator on it. And it just change the pointers and move iterator to next element. Just in simple list. In place vector, it's size and members. I'm doing the flat thing, which I shouldn't do, but I didn't have any way how to visualize it properly. So sorry. And content is just based on the size, and I can put items there. Capacity is fixed, and I cannot grow past the capacity. But there is a problem. Why in place vector is not Constexpr is because all the items needs to be initialized. And if your items are not trivially default initializable, then they cannot be initialized in Constexpr. And it will fail because it's an array and it must be initialized. We need to fix that. Deque. Deque is magical data structure no one uses. You have 5 members, prefix capacity, suffix capacity, and middle vector in middle of it, which points at leaves of the Deque. And leaves are always the same size. And there is some space in front, in prefix, or in the suffix. And the leaves are always the same size. That's important. So why it gives you kind of contiguous storage for leaves, and it gives you O1 adding in front and in back. So why almost no one is using explicitly Deque? I think you know your answer in your heart. ABI. Because some implementers, and I'm not going to point my fingers, MSCC, they do really small leaves. I think it's 16 bytes or 2 items. So it's basically a list with vector. So it's useless. But on libc++ and I think standard in GCC, they are 4 kilobytes. So they are page size. So it's really useful. But you need to know your platform. So these all seems really easy to implement. Why is only vector and string, and also array and optional Constexpr? But mostly vector and string. Do any of you know answer? Not Guy, because he already saw this talk. And he's also sleeping in front, by the way. So, is there any answer for that? I heard because they are most used. Vector is allocating, string is also allocating. So because okay, there are so many answers. Answer is this. Because in Cologne meeting 2018, there was a last slot in a library working group for review, and I bribed Marshall with chocolate to put this into standard. Because there was a lot of paper which was fighting for the last slot, and this was actually small. So we have these for 1 chocolate. It cost me €2. But I didn't write the paper. That's Louis Dion. So I just was doing the politics behind with chocolate. Okay, but C++ language and library is improving with every version. It gets better. So let's look at Constexpr status. Since when you can use if, for, and while in Constexpr? Which version? Just shout. 14. Not front. You are banned. 14, yes. Variables. Since when you can use variables in Constexpr? Because originally it was just constant expression, no variables. But arguments were actually variables, so Also 14. Calling lambdas. Anonymous object, like anonymous lambdas. Since when? '17. Trivial default initialization. So you can actually put variable in your function without initializing it, and it will be somehow trivially initialized. 20. Try catch. Can you have try catch in Constexpr? Raise your hand if you think so. Only a few people think, oh, you can since 20, but you cannot catch at anything because there is no throwing of exceptions. Okay, you can change active member of union since when? Not just initialize it, but also change the member of union. 14? 17? 20? You know that. Not committee member, please. 20. Inline assembly. Can you have inline assembly in Constexpr? Yes, you can since 20, but it must not be evaluated. For 20, we change meaning of Constexpr from must be constant evaluatable to there is maybe some part which is Constexpr compatible, or maybe none. Atomic operations. Can you use atomic operations in Constexpr? Yes? No? You are all wrong. 26 allows that since 2 days ago. Exception throwing. Can you throw exception in Constexpr? Yes, you can since 2 days ago. Can you have initialized array members? Not yet, but maybe on next meeting. Virtual basis. Can you have virtual basis of your types in C++ in Constexpr? I see like people doing like this. Or this. I don't know. It's just noise. No, you cannot. Can you have virtual functions in C++ in objects in Constexpr? Yes. OK. Can you use byte array as object storage? Like I have bytes and I will store object there? No, you cannot. But maybe someday we will do something about it. Can you use reinterpret cast? The cast of the OD cast, which will do everything you ask it, but you don't know what you are asking it for? No, and I hope never. So Constexpr still needs some improvements, obviously. But this talk is about data structures, and I have my favorite data structure, which was actually my motivation for this talk when I started, and also for my papers in the committee to actually allow to implement it. And it's a cool one. And we have just a little bit of time, but it's enough. It's called, It has O1 insert search delete. It gives you linear growth. I know I have typo there. I didn't fix this. No rehashing. So you don't need to rehash. It grows like Trie, so it's like a linear growth, so you don't need to. It can be log-free. It can be persistent. Do you want to know what is it? And also, you can use it in flat storage. Sorry, I didn't know. It's 6. OK. It's called AHMT, hash array mapped Trie. Trie is proper pronunciation. It's all the cool words like cloud and blockchain and everything, but this one is actually cool. It was invented in 2000 and a log-free version 2011. It's new. And I think it's so simple that everyone in this room could invent it. So you have root, which is just one pointer, and you have leaf with item you are searching for, and it has some hash. It's big hash, but it's just 16-bit. Yeah, it's big one. You have level 1 of the structure, which is 16 pointers, and you use first 4 bits of the hash, 4 in this case, to navigate to level 2. And then you use E, next 4 bits, to navigate to next level. And then you use 8 and F, and that's how you find your element. Yeah, I'm fine. Thank you. And you can have obviously multiple. It's a tree, so it looks like this. But also, you can have even leaves from in upper levels if there is no conflict for them. So if you know that there is no other item with same hash or some same prefix hash, then you can put it in a higher level or even to first level, simply. But if you have multiple items with same hash, so you need to put a hash function, what's happening? Yeah, sorry. To distinguish what's a leaf and what's level or node, you need pointer tagging. So you put information into pointer because pointer at hardware or even symbolic pointer can have some more information. So I'm using 1 bit of information to tell you or the program what's the leaf. So you can. There is 1 bit here and up there, which points what's the leaf. And obviously, you can have also more items with same hash. So you need to use better hash function. But if not, then it's a kind of hash table. But it grows linearly, but it's wasteful. There is a lot of null pointers. And I don't like them. So let's compress the nodes. Just use bitmap to give you information what each node is actually used, and everything else is virtually semantically just null. And you can do this. And suddenly it's much smaller and nicer data structure. Or you can use pointers which are atomic, and put them in front of each level, including level 1, which is on the top, and each leaf. And then just change them, and you can compare exchange them log-free if you go from the bottom to the top, and you don't need to log in between multiple threads. Or let's forget about the atomic pointers. You can use ref counting for each node and leaves, obviously. And you can have multiple copies of your data structure sharing nodes. So you don't need to log also. You just will create new copy. And the copy just contains only the changes. And if you destroy the old one, it will still hold because it's ref counted. I have wrote, and so I have like 2 copies. Also, if you exchange pointers with offsets, you can just use them in flat storage. Like this. And then, at the end of the file, probably because flat storage is usually just file, the last node, last offset, like last value with offset, is root of your data structure. So whole data structure is just current state of your data structure. But also, you can have subview, some prefix, and you can have snapshot of previous version. So you can use this data structure in flat storage as a transaction log, maybe, or database. And it will hold all the values because you are just appending. You are not changing anything. And that's my favorite data structure. But for future, because we like C++, at least I do, and maybe Guy, there are some papers which improve C++. Exception throwing was accepted 2 days ago. Constexpr exception types, so like runtime error, logic error will be Constexpr. Atomics were accepted too. Constexpr shared pointer from Paul Kier, which will make shared pointer usable in Constexpr. Pointer tagging, which will allow you to store some small information, few bits into pointer, even in Constexpr. Trivial unions, which maybe will allow you to have array which is not fully initialized. Constexpr containers and adapters. Every container adapter should be Constexpr. Also, freestanding Constexpr containers and Constexpr exception types. It's a paper which will, for people working in embed or hardware development or firmwares, allow to use standard library, including containers and exceptions, but only in compile time. In runtime, they won't be there. So no allocations you don't know about, but for compile time, you can build things with Constexpr. Constexpr coroutines. Constexpr stat format. Constexpr stud generator. And also there is a paper from Jeff Snyder, which will allow you to allocate something in Constexpr and like vector and store it in a way that it will be in runtime with almost zero overhead. Like overhead will be just like pointer randomization and nothing else. The object will be just there. And you can just read it from it and do cons or even mutable operations in some cases. Yeah, thank you. That's my favorite conceptual data structures.
Thank you so much, Hana, for this engaging talk. I think we've got time for one or two quick questions, please. Is anybody interested? Questions? I could see you all amazed.
I'm afraid that there is someone. Yes. Because it's hard to not have any question. Did you get it? Or am I on one conference? Maybe medical conference? I don't know.
Okay, it works. Okay. Hello. You said that this abstract machine of C++ is one file, but this is the rest of Clang uses the same abstract tree as this Constexpr evaluator, or this is abstract tree and all of that written only for the const expression evaluation?
Okay, if I heard correctly, I have bad hearing, sorry. This is the first part of the talk, as I showed, is how Clang is evaluating C++. And because Clang is designed to be compiler, there are essentially two different parts. You do all the parsing, and then if you want to evaluate something, you need to use interpreter, because you just interpret C++. And if you compile it, you need to lower it into LLVM-IR and into assembly. And then you go. I imagine a world where you can just take libclang, link it with Chrome, and have like HTML tag, script, language, C++. Because it's just interpreted language, nothing else.
Yes, but this AST is shared between the rest of Clang and this.
Yeah, the parser is obviously shared. Like Clang is much bigger than just Expr.
That's why I'm asking, because you said that that whole evaluation is in this file. So I was wondering what is reused from the rest of the Clang, yes, because
I mean, there is a lot of things reusable in the rest of the Clang. There is some interface which allows you to use this machinery from outside of this file. So if there is something which can be used somewhere else, it's obviously available, not just there.
Okay, thanks.
Okay.
Thank you so much. Perhaps one more. Just over there, suddenly an explosion of questions.
Hi, so I have questions about this Humpty structure. Is it like similar in spirit to this, I forgot the name, but is it similar to this thing that is used to map virtual addresses to physical addresses?
Oh, no. Like translation between virtual address and physical address is done by processor.
But it's like, I feel like it's very similar in like spirit.
No, this is much more abstract. You have much more information about what's where, and you can go always only down. You cannot go up, and it's just abstract data structure. It's not something which is happening in the processor. Processor needs to be much more optimized and quicker. So there can be also like problems, and that lets us to like things like meltdown and spectre, because you don't have much information to do this. But Constexpr C++ is safe C++.
Okay, thanks.
Yeah.
Thank you so much. I think perhaps the rest of the questions you might want to take off stage.
Okay.
Hana, we need to rearrange the stage now for our next speaker. So everybody, let's show our applause to Hana Dusíková.